Assalamualaikum, sir.
Walaikum assalam. So since only 36 students have joined, please share the link with others and ask them to join, please. I have shared this Zoom link in the Google Classroom.
Grande.
Okay, so I think we can start. I can see that more than 60 students have joined. Okay, thank you for joining. And uh, it's a makeup class of last Tuesday, and unfortunately, I cannot make today's morning class. So that's why I have invited both the sections for the Tuesday class and this class, this morning class as a whole. Uh, and I think both the section students have joined in this class. So today I will start a new lecture. The thing is that I have started lecture 9 in your last class, but I like to complete that lecture in person so that uh, the lecture 9 on interrupt I have started in my last class on Friday, and I like to finish that lecture in person. So that's why I'm not continuing that lecture 9 today. Rather, I'll start lecture 10 today. And lecture 9 will be completed, inshallah, tomorrow in the regular classes. Okay. So I think my screen is visible to all of you. Is it? Can anyone respond?
Yes, sir.
Let's have a full screen. So this is the very first lecture after 8085. Then we have started talking about 8086 and so many things we have learned about 8086. Why we have considered 8086 as a base microprocessor? Because it is found as the most versatile microprocessor that has created all the provision. It is not the case that 8086 has implemented all the functions, but it has created all the provisions, and on those provisions, the further microprocessors has been developed. And as a part of that consequence, the very first microprocessor that was evolved is 80186 microprocessor, and thereupon uh, the next microprocessor is the 80286 microprocessor. Okay. So today I'm starting with lecture 10 with both the microprocessors. You can imagine or you can assume that both the microprocessors will be covered in a single lecture. So let's start. So till now, the microprocessors we have studied, as already I have mentioned, is that first with 8085, then 8086. Then I like to make a recall the concept that thereupon the X8 series, we say in short, it's called X8 series. In fact, it's 808 X8 series, and X can be considered as a variable. And so we have the 186, 286, and we'll cover those two in this lecture. Then upcoming is 386 and 486. So four versions will be covered in our coming 2 or 3 lectures. And thereupon we'll move to the Pentium, and after that the multi-core environment. So in 186, this is the basic information about the 186 microprocessor. So what we can see that in 18086 contains which microprocessor? The 8086 processor, but with several additional functional chips. That means 8086 has been incorporated with the 80186. That means the processor capacity has not that much increased, but some additional functional chips or ICs are incorporated with that of 8086 microprocessor. So what are those additional functional chips? One is clock generator. Maybe you have seen in my system bus timing diagram where I have shown you the clock generator circuit and how the clock pulses are reaches to the microprocessor through pin number 19. I have shown you. Then there are two independent DMA channels. You know the term DMA. DMA is the direct memory access. And earlier it was only one channel, but 808186 has incorporated two DMA channels. Nowadays, you can see that in our motherboard or in the main board, multiple USB interfaces are there. Maybe in regular desktops, in front side, we have 4. In the back side, we have 4. So total 8. So these all can be treated as the DMA channels. But in 808186, we had two independent DMA channels. Then the ICs, we have some programmable ICs. The concept of programmable ICs, actually in this course, will not talk a lot about the programmable ICs. Rather, we're talking about the processor, and processor itself a programmable IC. Processor itself a programmable IC. But apart from the processor, we have some other ICs. Like I'll explain the concept here. Is that suppose this is our CPU or processor, and we have the input device, then we have the output device, and this input and output device uh, is not directly connected with the microprocessor. Rather, we have some intermediate ICs. We say it's PIC, programmable IC. Sometimes this programmable IC is called PPI, programmable peripheral interface. You can say USB is a programmable peripheral interface that will connect the input device or output device. So this is treated as a programmable peripheral interface. Then we have some other IC, we say that is PIC, programmable interrupt controller. It is for interrupt. We say programmable interrupt controller, PIC. Then we have some other IC, PIT, programmable interval timer, PIT. Apart from this, we have the DMA controller. So you see that so many programmable ICs. One is programmable peripheral interface, programmable interrupt controller, programmable interval timer, then DMA controller. So these all are assisted ICs or programmable ICs. Those are connected to the CPU. Actually, we will not talk a lot about these interface ICs. Rather, these ICs will be covered in your peripherals course. In the next semester, we have a course, peripherals and interfacing. So about these ICs, programmable interrupt controller, programmable peripheral interface, programmable interval timer, and programmable DMA controller. About those ICs, we'll talk about that in that course. But so that provision, programmable ICs, the inclusion of the programmable ICs has been introduced with 80186 microprocessor. But you may consider that, you may recall that in 8086 microprocessor, this can operate in two modes. One is minimum mode, that is a single board processor. Single board processor, we don't need multiple ICs. Rather, in a single board, all the components are incorporated. But 8086 has another mode that is called another mode that is the maximum mode. You can consider that multiple ICs are integrated in a single motherboard, and in therefore the computation system becomes a bit complex, but that gives much more flexibility to us. So in that aspect, the programmable ICs are incorporated to 8086 to build up 80186. And finally, the timer. I have told you the programmable interval timer. So there are three programmable 16-bit timers are there. And why do we need the timers? To compute, to measure the time, to compute the processings, the number of processings, or the number of executions, the number of instructions. So several things needs to be counted. For counting those, we need the timer circuits. So there are three programmable 16-bit timers. You know that using one timer, we can calculate 2 to the 16 counts. So using three 16-bit timers, so 3 into 2 to the 16 counts are possible. So these are the additional features that has enriched the 8086 microprocessor to build up or to make it the 80186 microprocessor. But in the microprocessor industry, the 80186 is treated as more of a microcontroller than a microprocessor, because you know that 8086 microprocessor maybe most approximately it has ruled the market for 15 years. For 15 years. So thereupon, the application demand, the processing demand, the computation demands has increased a lot. So in that era, the considering the processing demands, the 80186 cannot or could not meet up the processing demands. So that's why it was used only for some target oriented computation. So in that aspect, it is called more of a microcontroller than microprocessor. And for what applications it was used? It was used mostly for industrial control applications. You know that there is some PLC, then programmable logic controller for controlling the small devices. It was used. So that's why 80186 was called almost like a microcontroller. Next, let's proceed. So this is all about the 80186. So there is not much to talk about the 80186. If you ask me, sir, what is the RAM size? So I will say that 80186 80186 has the data bus size, if I consider, or address bus size, if I say, so the data bus size is 16 bit and address bus size is 20 bit for 8086 because it follows the same structure of 8086 microprocessor. Nothing new, only or except these four components are added with that of 8086 microprocessor. So I think it's clear to all. So what is our 80186 microprocessor? So nothing to talk more about the 80186. So let's proceed with the 80286. So after the dominance of 8086 microprocessor, at the start of the 90s, the Intel has introduced the 80286 microprocessor, and it was considered as a high performance microprocessor with memory management and protection. So, which makes it more unique is the concept of the memory management and protection. What is memory management and what is protection? I will come to that point. So, the first is that 80286 is the first member of the microprocessor family of advanced microprocessors with, with built-in or on-chip memory management and protection abilities. And it was primarily designed for multi-user and multitasking systems. So multi-user and multitasking was possible. Through multi-users, multitasking was possible through the 80286 microprocessor. And the clock speed, you know that what was the maximum clock speed of 8086, that the 10 megahertz, and the 80286 was operated with three clock speeds, 8 megahertz, 10 megahertz, and 12.5 megahertz clock frequencies. So let us know more about some details. Is that the introduction was made in 1982, but it was vastly available from the start of the 90s, and it has 16 megabyte of addressable RAM. So now here is the question that what was the 8086 RAM size? That was only 1 megabyte. That was only uh, for it. For 8086, the RAM size was only 1 megabyte, whereas 16 megabyte. How? That means there is a huge change or huge enhancement in the address bus size. Okay, you know that with the 2 to the 20, we have I think this is the 576 most probably. Okay. So these amounts of memory locations or 2 to the 20 is the address bus. But in this case, we have the address bus size of 2 to the 24, and that provides us a RAM size of 16 megabyte. So this is one enhancement with that 80286 microprocessor. And thereupon the most important feature of 80286 it is the concept of protected memory. What is protected memory? I will explain in coming lectures. Then 80286 is much more faster than 80286 because you know that the RAM size is 1 megabyte, and here is the RAM size of 16 megabyte. And also it has introduced with the coprocessor, we call it coprocessor for 80287 floating point unit. One thing to mention, I think whenever you are using the emulator, you were not able to write up the floating point numbers in any kind of experiment because we don't have any fraction values there. Only the round of values or the ceiling values were identified in the emulator of 8086 microprocessor. But in 80286, there was a co-processor named 80287 that was introduced with the floating point unit, and that can deal with the floating point operations. So this is the very first microprocessor after 8086 that can handle fractional values or floating point numbers. So there are 134,000 transistors. You know that the increasing of the, why I am pointing the number of transistors, because at the end of the Pentium, I'll I will call before the introduction why we have been guided to the multi-core processors, uh, to understand that situation. We should know that how the only the increasing the number of transistors couldn't help us to increase the processing speed. Though as an initial state, the number of transistors were doubled or increased uh, a much more times than the earlier microprocessors, but only increasing the number of transistors at once, it was identified that it couldn't help us to increase the processing speed. Anyway, that's a different talk. About that talk, I will talk about while I will talk about the multi-core processors. But for today, you can know that 80286 microprocessor includes 134K transistors. Okay, so here is a brief comparison between these three microprocessors. You see that we have the 8086, we have the 80186, then 80286. One common feature is that all of them have the same data bus size. So that the data size, sorry, the data size we have is the 16-bit. Where is the change? The only change is in the address bus. And you see the only increasing a number of 4 bits in the address bus, and the memory size has been increased 16 times. So this is one huge advancement towards the microprocessor of 80286 after 8086 or 186. So this is the 16 megabyte of RAM or physical memory. And another feature is that it was introduced with the concept of with the concept of virtual memory. We didn't talk about anything about the virtual memory in our 8086 or 186 related talk, but the concept of virtual memory was introduced first with the 80286 microprocessor. And I'll show you what is the concept of virtual memory. And maximum 1 gigabyte of virtual memory uh, can be allocated for each task. Okay, so about the 80286, there are two operating modes. One, we call it real address mode, and another we call it protected virtual address mode. So let me explain these two. One is real address mode, is that uh, we'll use the uh, same. Someone is wanting to record my lecture. Is it necessary? Isam, are you there?
Yes, sir. I actually I clicked by the mistake. Yeah, you can decline it.
Okay, so I think it's not mandatory, because sometimes one thing to share informally, that sometimes I may talk informally, and maybe I don't want to uh, record that part for my lecture. But if you want, if anything you don't understand in this online class, it will be better to discuss with me while we'll meet in the IoT in person. So that will be a good idea. Anyway, so Uh, there are two modes, two operating modes. One is the real address mode, and another is the protected virtual address mode. So let me explain these two addressing modes of 80286 microprocessor. The first thing is that the 80286, while it operates into the real address mode, it operates likewise the way we have seen in 8086. So what we can say that the first 1 MB of memory is called the real memory or the conventional memory, and we have the only operating system that is the DOS operating system or disk OS, disk operating system, or later on the Microsoft has the version that MS-DOS, and at that operating system, at that operating mode, we had the address bus. You see, in my last class, I had talked about the odd bank and even bank, even bank of memory. In the odd bank or even bank, in case of even bank, you can say that 1, 2, 3, 4, 5, 6. 6 hex characters are there. That means total 24 bits. So 24 bits of address you can see, and we have the next address is all 0 then 1. It is the next address. It's an odd address. So that this way we have total 8 MB of odd memory bank, 8 MB of even memory bank. So 8 MB of odd memory bank and 8 MB of even memory bank altogether makes the 16 MB of RAM. So this is how the memories are allocated. The same way, if I draw the memory of 8086, what is the difference? I will just tell you that 00001, then it is the odd bank, and we have the 00000. So these all are in hexa. So this is the even bank. Then we have the 00002 H, and we have the, this is the 00003. And this will be the last one. F, 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 F. And this is the second last one, is that F, 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 E. So this was the even memory bank, and this was the odd memory bank. Now, why I have drawn that? You know that here we have the total 512 kilobyte of RAM. Here we have the 512 kilobyte of the RAM. I am drawing this memory for which microprocessor? For 8086 microprocessor, because you have already studied these concepts, and if you can understand the operating principles of 8086, I think the further microprocessor operations can be easily be understandable by you guys, inshallah. So we have that total 512 kilobyte and 512 kilobyte altogether, it makes 1 MB of RAM. And this 1 MB of RAM actually called as real memory. It is called real memory. And you know that the 8086 was operated through the command-based operating system, that is the DOS operating system. I have told you that total 117 instructions altogether defines the operating system of 8086 microprocessor. In the similar way, while the 80286 microprocessor works in the real address mode, it only uses 1 MB of memory. So though it has the memory size of 16 MB, but the initial 1 MB the initial 1 MB it uses for the real memory as a real memory or as a conventional memory to run it in the real address mode. So that means it works with the command prompt mode or command based operating system. So in real address mode, which is not allowed, the Windows does not use the real mode. And the concept of segment and offset is used here to identify the segment of 1 MB. And it is single task. It is single tasking. That means uh, in 80286, if we run it in real address mode, we cannot have the full flexibility of multitasking or multi-user use uh, in 80286. It only deals in the single tasking with only 1 MB of RAM. We cannot exploit rest of the 15 MB of RAM. So to exploit or to utilize the rest of the 16 MB of RAM, what option we have? We have the option of protected virtual mode. Actually, this is the efficient mode of 80286 microprocessor. So let me talk about something about this protected virtual address mode. As you know that we have the 16 MB of physical memory or RAM, and it provides up to 1 GB of range of virtual memory. Now you can say that how it provides a provision of virtual memory. Actually, that's a different memory management issue, and hopefully in lecture 12, today I'm talking about lecture 10, lecture 11, or lecture 12, or in lecture 13. I have a details talk about the memory management where we have the, but today I will give you some concept of memory management. Suppose here is our CPU. CPU is directly connected with the RAM. That means RAM is our physical memory. And you know that we have the secondary memory. And in early days, we have used the hard disk drives as a secondary memory. Nowadays, we are using the HDD or solid disk drive. We are using. But the concept is that what is the virtual memory? The virtual memory is that the CPU will utilize some memory portion of the RAM to point some memory portion of the secondary memory. Some memory portion of the secondary memory. So the details mechanism I'll talk about in the lecture 12 or in lecture 13. But for today's class, what I like to mention that here is the concept of pointer is that the CPU will point or address the physical memory or RAM that is directly connected in the motherboard. And from there, the RAM locations or the physical memory locations will point a huge amounts of memory from the secondary memory part or the from the hard disk or the solid state disk. And this will create a provision of maximum what? 1 GB of RAM. So through 16 MB of memory, so here is our 16 MB of RAM. This from this using this 16 MB of RAM, we can maximum locate or point 1 GB of virtual memory. And this was designed for multitasking and also for Windows operating system. You know that Windows operating system can run in graphical user interface. And one concept to mention that while we install the Windows operating system, we have to make a primary partition in our hard disk. And you know that in our hard disk drive, we have to install the Windows in the primary partition. Typically, we use the C drive. for installing our Windows operating system, and we have to spare some portion of the memory from the secondary hard disk or secondary memory uh, for installing our Windows operating system. And what is an operating system? An operating system is a collection of instructions that several times I have told you. So this is the concept of protected virtual address mode. And in protected mode, we can run the Windows operating system. So that means from here, if I ask you that from which microprocessor the Windows has operated has started its operation, we should know that that is the Intel 80286 microprocessor. I have used the very first Windows operating system, that the Windows 95. Thereupon, maybe I have used the MS-DOS. Thereupon, we have used the Windows uh, 95, then Windows 97. Most probably, our bachelor has started with Windows 97. Then we had the Windows 2000. Then, as 2000 was the year of millennium, there was another version called Windows Millennium. So you see, Microsoft has generated with lots of operating systems with the advancements of the processor industry. And thereupon, we had the Windows XP. It was a long-lasted operating system, Windows XP. Maybe some of you may have that experience to use that Windows XP. Then most probably we have the Windows 2007, then to Windows 2008, then we have the Windows 2010, 11. This is how the Windows operating system has its advancements, with the advancements in the microprocessor's capacity as well. Okay. So I think just a minute. So I think I have tried to give you the idea of the concepts of protected mode operation. In protected mode operation, both the physical memory and the secondary memory works together. And typically, we use the physical memory to point out some portion of the secondary memory. And that is called the virtual memory. And it was designed for multitasking and for Windows operating system as well. So we have a details of memory management unit. Maybe if I can't cover the uh, structure of the 80286 microprocessor, uh, you will not be understand. You will not understand the total concept of memory management unit, but some brief details I can say. You can you can see that 80286 switches to protected mode and it start its virtual memory. So it can operate in real mode or in protected mode. You know that in protected mode, and we have the real mode. In real mode, we have to use only 1 MB of RAM. But in protected mode, we can use the 16 MB of RAM, and through that 16 MB of RAM, we can point 1 GB of secondary memory or virtual memory. So you see, so it's the most challenging part and the most interesting part of 80286 microprocessor. And thereupon, in protected mode, the concept of segment was not used. You know that in 8086, we have used the concept of segment and offset. So no longer we'll use the concept of segment. What we'll use? We'll use the 16-bit selector value. We'll use the 16-bit offset value. The offset concept will be there, but instead of segment, we'll use a 16-bit selector. And those 16-bit selector will access a descriptor from the memory, and that will identify a desired segment in a table of descriptors. So a descriptor is called a table, and we can access the descriptor table using a 16-bit selector value, and thereupon those 16 the descriptors can describe total 64 kilobyte of memory segment from the secondary memory, and we have total 16 thousands of descriptors. So in total, 64 kilobyte of one memory segment from the secondary memory with 16 thousands of descriptors. So if we can multiply these two, we will get a maximum 1 gigabyte of secondary memory. And those secondary memory is called the virtual memory. So you see, uh, it's a summarized description. You can consider that how the memory management of memory management unit is designed. So what I can summarize is that we have a 16-bit selector instead of 16-bit segment. We have the 16-bit offset. These two altogether access the memory, and from that memory, we will find a descriptor table. And in those descriptor table, we have total 16 thousands of descriptors. Each of the descriptors can point from the secondary memory, it can point 64 kilobytes of secondary memory. So in total, 64 kilobyte into 16,000, we will get 1 gigabyte of secondary memory as a virtual memory. I think while I have talked about the concept, uh, again, I'm relating that part, is that we have the CPU. From the RAM, we will have a table of 16,000 descriptors. These descriptors can point one segment with 64 kilobyte. So in total, 16,000 means this way we can have total 64 kilobytes of segment from the HDD or from the secondary hard disk or secondary memory, 64 kilobyte of secondary memory. So 16,000 descriptor multiplied by 64 kilobyte, we'll get total 1 gigabyte from the hard disk. Our hard disk size at that era of 90s, it was only 500 megabyte, 512 megabyte, or less than that. But this concept was introduced at that era. So it's a very logical concept. The details, inshallah, you'll see in lecture 13. Okay, let's proceed. Okay, are you getting my class? Any
Yes, sir.
feedback? Good. Okay, next, let's have some other features of 80286. So you can see some trademarks of Intel in 1982. It was introduced. You see the AMD, it was called AMD microprocessor. Later, some version was called Athlon microprocessor, and it's 16-bit of data bus size, but the processor name, you can see 80286. So what happened when the 80286 includes some special instructions to support the operating system? So some special instructions was used. One instruction can end the current task. As you know, the 80286 supports multitasking. So while ending the current task, the states of that current task was stored, and we can switch to a new task, and we can it can load the new states and begin the executing the new task. Actually, if I can start the today's lecture after completion of the interrupt lecture, you could have understand it better. But tomorrow, inshallah, in person, I will finish the concept of the interrupt. So it is something like that. That current task will be halted, and thereupon the system will go to the new task, and it will load the new states for the new task, and it will begin execution of the new task. So what is the difference? Actually, interrupt is a special kind of program, but task is the regular programs. So multiple users are there, multiple users, different users may have different tasks. So there is some task priority that is defined by 80286, and based on those task priorities, we can switch from one task to another. But of course, while executing the current task, if we can switch to a highly prioritized task, in that case, the previous task information should be stored. And in total, earlier, what we have seen for 8086 microprocessor, we have seen dual inline package, but you can see that the pins are arranged in every edge of the microprocessor. So in total, earlier we have seen 40 pin package for 8086, and we have studied those 40 pins package. After our meet, I have completed one lecture, that is the 8086 hardware specifications, where I have explained all the 40 pins operations in details. But here you can see that we have 16 pins in every edge. So in total, sorry, 17 pins in every edge, and in total we have 68 pin package, and with 1,34K transistors. So the internal block diagram of 80286 looks like this, and we have a comparison. We have a comparison among the microprocessors, those we have covered till now in this course. We have covered uh, the simplest things about a microprocessor, that is the 8085 microprocessor. And after that, we have covered in details uh, operations of microprocessor using the 8086 microprocessor. We have seen all the operations related to the microprocessor based on the 8086 microprocessor. And there we have seen two units. One is called execution unit, where the ALU, if you can recall, I'm reminding you that in execution unit, we have the ALU, we had the segment registers, I'm sorry, segment registers not here. We have the general purpose registers, GP registers, we have the index registers, we have the pointer registers, all resides into the execution unit. Only the segment registers and IP, these 5 registers resides into the bus interface unit, because these 2 registers, segment and instruction pointer, derives the address bus, and thereupon this connects to the RAM. So this is how it works. Only 2 units were there, but 808286 was segmented into 4 units. One is the execution unit, one is address unit, one is bus unit, and one is instruction unit. So total 4 units are there. So it is more distributed, and more functionalities are incorporated in 80286. Execution unit, address unit, bus unit, and instruction unit. Sorry. So the internal block diagram, it's a bit complex, than that of 8086. And one thing to mention, while I have talked about any microprocessor, I have a detailed discussion on the architecture of the microprocessor, that the architectural block diagram. I have a detailed discussion about the architectural block diagram. Okay. So one is address unit. You can see we have the bus unit, we have the instruction unit, and we have the execution unit. So, so let's start something, uh, some discussion about the internal block diagrams. The first one is that to provide the address. So what is the address size? Anyone can respond? What is the address size or address bus size for 80286?
So 24 bits.
4 bits. Okay, you can see the 24 bits are written or
Next
are
that like this
generated. Uh, Marine or okay. I think it's tough to have the class from home or at night. It's almost 1 hour class. Okay, I'll finish. Hopefully, I'll finish very soon. I think I don't know who is getting tired. Anyway, so what I was talking about, that you can see the bus unit. Bus units. What is responsible of bus unit is that it generates the address. Already you have that knowledge that always the address is provided by the microprocessor. So who generates the address? The answer is very straightforward. The answer is that uh, microprocessor generates the address. So that is why we say address bus is unidirectional. It's not bidirectional. So that is why you can see in this figure that we have a 24 bit, we have 24 bits address bus, and that is generated unidirectionally towards memory. So you can consider this is the memory. Okay. Another thing is that you see we have a separate data bus. What is the data bus size? It is the 16 bit. You are already know that this is the data bus size, and data bus size is 16 bit and it is bidirectional. You can see it's bidirectional. So bus unit is responsible to provide the address to us the memory, and from the memory it will collect the data. So data transceiver means either it will send the data transmit or send the data, or it will receive, or uh, it will read the data. And once the data is received, the same concept of 6 byte prefetch queue, you can recall that the same 6 byte prefetch queue was there in 8086. Here it is uh, also used the 6 byte prefetch queue, and that is also part of the bus unit. From there, the instructions are, instruction reach to the instruction unit. That this is the second part of the microprocessor. There is the instruction decoder, and the decoder decodes the instruction and it stores into a chi decoded instruction queue. And from there, the instruction goes to the control unit to the ALU. Here is our ALU. And you know that we have a set of registers. We have a set of registers that resides near to the ALU into the execution unit. So the flow, what is the flow of the what is the flow? Is that the first it provides the this is the one flow one. The address is provided by the microprocessor. Flow two is that from the memory, the instruction will be collected through the data bus, and through the data transceiver, it will be stored into the 6 byte prefetch queue, and from there it will be decoded. We know that instruction fetch, then instruction decode, then operand fetch, then execution. So these are the 4 steps we know. for executing one instruction. So we have the one for addressing through 24-bit address bus. Then from the memory, we'll collect this maximum 16-bit of instruction, and this is how the instruction will be stored into the 6-byte prefetch queue. And from there, the instruction will be decoded. And once it is decoded, there is a 3 decoded instruction queue. And from there, the instruction will be available to the microprocessor, and the microprocessor will execute and store the results into different registers. Now, to generate the address, the concept what I have shown you, we have the offset adder, we have some selector, and we have the the address unit a bit complex. You know that we have the concept of virtual memory. So how to deal with this virtual memory, I'll discuss about the operations of address unit in my next lecture. Not today, not tomorrow, in the next lecture. Okay. So as it is an online class, I think I should stop here. And I think it's almost 1 hour, and uh, many of you are at your home. So I think it's better to stop up to this. And the next portion of this lecture will be completed in person, hopefully in next week. So let me have some quick random uh, attendance, not all. So what I will ask is that, 2 minute, just a minute. Hold on, please. Okay, so let's have a quick attendance. Some random attendance. It's not possible for me to call everyone's name. It will be better have some random attendance. So let's see your luck. Okay, first from section 1. Which numbers I should call? Okay, roll 10. Are you there?
Yes, sir.
Good. Then roll 11.
Present, sir.
Good. Roll 18. Roll 18. Are you there? From section 1. No, he's not here. Okay, roll 22.
Present, sir. 20.
Okay, no problem. I'm calling it randomly.
Sir, 22 present.
Okay. Roll 27.
Yes, sir.
Good. Then roll 32.
Yes, sir. Yes, sir.
Maru. 34. Four is not here.
Yes, sir.
34.
Yes, sir.
But your ID is showing 39.
Sir, I'm in the
Okay.
hall, sir. Sir, my mic doesn't work properly in the PC.
Okay. Roll 43.
Could you turn on the camera?
No problem. No problem. I do believe my students. No problem. 41 or
Thank you,
43.
sir. Thank you, sir.
41.
Sir, 41, sir.
43. 43. Are you there? I guess no. Okay, 47.
Sir,
Present,
roll
sir.
43, sir.
Okay, wait. 48. 48.
Hello, hello, sir. Sir, roll 43, sir.
Okay. So you're using a different people mic?
Yes, sir. I was talking, but you couldn't listen. I gave the present, but it was defective, sir.
Okay. So roll 65. 65 from section 1. Ibrahim Sani Abu Bakr, are you 65? Okay, from TV students, roll 5. Ibrahim Musa, are you there? Okay. Next, from section 2. Section 2. Roll 3.